the sample space where you got when two cards are selected without replacement labeled 1 to 7?
14.
Not 14.
Oh, God. Without replacement.
Yeah.
See, I've got no clue.
Okay, cool. So this is called the multiplication principle. So you're choosing how many cards?
7.
Oh, you're choosing two cards.
Oh, okay, yeah.
Yep. But you're choosing them from a deck of 7. Okay?
Yeah.
7 cards to choose from, but you're choosing 2. So you got 2 choices, yeah? You got choice 1, okay? And then you got choice 2. First choice and second choice. Okay? So how many cards are possible to be chosen in our first choice? So in other words, what would be our sample space for the first choice?
Well, anyone between 1 and 7.
Yeah. So how many cards would there be?
7.
7. Good. All right. Once the first card has been chosen, how many cards are left over?
Oh, 6.
6. Yep. And so how many elements? Now, elements just means how many combinations, I suppose.
Yeah.
Can you have?
Well, 7 times 6.
Yeah, it's the multiplication principle.
Right.
So your answer is 42. Got it?
Yeah, okay.
Yeah.
Without replacement, okay.
Yeah. A 3-digit number is formed from the digits 5, 7, 8, and 9. What is the probability that the number will be odd? Okay, so you got 5, 7, 8, and 9. How can you work this out? Any ideas off the top of your head?
Well, there's 3 odds in that. Wherever 4.
Yep.
Okay. And then that into a decimal.
Yep.
0 C.
C. Is that right?
Yeah.
Yes, that's right. So you can basically, so if you were to arrange this as a 3-digit number, so you got 1, 2, 3. How do you make this 3-digit number odd? How do you make it odd?
Pick all the odd numbers.
Yep.
So 5, 7, 9.
Yep. What about, say, 5, 8, 9? Is that odd?
Yeah.
Okay, so what makes that odd?
On the last digit.
It's the last digit. In fact, that's the only digit we're worried about. Okay? This is the only digit that matters.
Mm.
And so, of how many choices are there? That how many choices can fit into that last digit?
What do you mean? How many choices?
So, how many possible numbers can fit into that last digit?
Are we still talking about that question, or is this?
Yep.
Just 9?
No, how many? Well, you're
5. They all can.
Yes. So the answer is how many?
3.
So how many numbers can fit into this last digit?
9.
Right. So 1, 2, 3.
Oh yeah. Okay. Yeah.
And how many will make this odd?
3.
Yeah. So 3 out of 4, which is 0.7.
Oh, okay. Yep. Okay.
Got it?
Yep.
Cool. Okay. One card is selected from cards labeled 1, 2, 3, 4, and 5. What is the probability of an even number or a number divisible by 5?
So there are 1, 2, 3, 4. Well, that was 5. There's 5 numbers, so it's out of 5.
Yep.
And even.
Yep.
2 even, and 1 multiple by 5.
Yep. So what would make this even? What would make... So which cards will make that?
Which card's even? The 2 and the 4?
2 and the 4, and which card was a multiple of 5?
5.
Yep. So
3 out of 5.
3 out of 5, which is?
Which is 75%.
Not 75%.
Wrong.
Close.
60%.
Yeah. Got it?
Yep.
Okay, a bag contains black, white, and grey balls. The probability of selecting a black ball is 0.3. And I'll write this down. And a grey ball is 0.6. What is the probability of selecting a white ball?
0.
Have a think. What should they all add up to?
Oh, okay. So it's got to add up to 1, does it?
1. Yep.
So that adds up to 0.8. So 0.2.
Yep. Oh, not quite. 0.3.
Oh, that's 0.9. So it's 0.1.
Yeah, 0.1. Okay, good.
Okay.
Okay. 6, a letter is chosen random from the word Newcastle. What is the probability that the letter will be a vowel?
So vowel is A-I-O-U. So Newcastle is 1, 2, 3. Did you get 9?
Sorry?
The 9 letters?
Yes, 9 letters, yes.
So 1, 2, 3.
Yes. So 3 out of?
9?
Yep. So which answer is that?
C.
C. Good. Okay, cool. All right, cool. This, I think, relative frequency. The frequency of an event is 6 and the total number of frequencies is 20. What is the relative frequency?
Could not tell you.
Okay, relative frequency is really easy, right? Relative frequency is basically how many times you did the experiment. Okay.
Yeah.
And this is the number of times you got what you were expecting or what you were looking for. Okay. So favorable outcomes.
Okay.
Okay. Now, in our situation, can you read the question? Can you see it, or is it?
Yeah.
Okay. So the frequency of an event is 6, right? So something happened 6 times. Something we wanted to see happened 6 times. The number of times we did the experiment was 20.
Okay.
So what is the relative frequency as a fraction?
6 over 20.
6 over 20, that's right. Okay, and then what we've got to do is turn that into a percentage.
Right. Times by 100.
Yep. I'll let you get your calculator.
30%.
Yes, 30%. That's correct. Okay. All right. Just going to make this slightly bigger.